Hey guys, we're on a roll with these videos. Today we're going to start with Chapter 1, Section 4, Measuring Angles. You're actually going to get to use some numbers today, so that's kind of exciting. The first thing we're going to talk about is an angle. It's important to know that an angle is formed by two rays, so two rays with the same end point. Where those angles, those rays are on the angle, that is actually the sides of the angle. So the two rays make up the angle, and where the angles meet is called the vertex. So it's basically where the two endpoints of those rays are, right where they meet, that's the vertex of the angle. I have a picture drawn up here so that hopefully you can get a good view of it. And now that I'm looking at this, it's hard to see this writing right here. Okay, so we want to talk about this angle right here. This ray, BA, and this ray, BC, they join together at this common endpoint, point B, which is called the vertex, right? Right here, B, the vertex. Right here along the sides, ray BC, that would be a side, and ray BA would also be a side. On the outside, where I have these dark green squiggles, you would call the exterior part of the angle, exterior of the angle. It's on the outside of the angle. Inside here, think of it like inside a crocodile's mouth in this light blue. There you would call it the interior of the angle, that inside portion of an angle. So we kind of want to talk about naming an angle. Right now, this angle right here, it has a number in it. Whenever there's a number inside of an angle, you can name it that way. So I would say angle 4. And because there are no angles adjacent to this angle right here, no other rays shooting off, I could name it by its vertex and call it angle B. I can also call it angle ABC, angle ABC, or I could call it angle CBA. The important part when naming an angle with 3 letters, those 3 letters, is the vertex always has to be in the middle, and you can't jump around. You have to go from one end, CBA, or start at the other end and go that direction. Okay, so let's look here. We'll get a more complicated angle. We're going to look at this angle, and the question is, what are other names for angle 1? Okay, well, I went ahead and I drew, you notice there's a couple angles here, but I highlighted this one in yellow so that you could see that this is actually angle 1. It's numbered. So we can't name it angle M, because if you notice there's this angle right here, angle 2, it's affiliated with angle M. This whole angle right here that's affiliated with angle M, and then this little angle, angle 1, that is affiliated with angle M. So we need to find a name for it. We're going to start here with J, and we're going to go down to M, so it would be angle JMK. Or we could go angle KMJ, as long as the vertex is in the middle and you're using the sides that actually make up the angle. Like I said, you must have the vertex as the middle letter when naming the angles. Okay, next page here. Classifying angles. Give me a second to get situated. And here we go, classifying angles. You're probably familiar with these terms down here. We're going to start with an acute angle. It's so cute and tiny. It's less than, and remember that's the symbol for less than, 90 degrees. So whatever this measure is inside of this angle, it has to be less than 90 degrees and greater than 0. So its measure is somewhere between 0 and 89 degrees, less than 90. Then we have a right angle. You know it's right because this little square is drawn inside that angle. And a right angle is just 90 degrees always. And then we move over to our obtuse angle. That's the big angle, the big chubby angle. All right, it's greater than 90, so it starts at 91 or 90.2, and then it's less than 180 degrees, right? So here's an example of an obtuse angle. It's clearly looking bigger than 90 degrees, and it's clearly smaller than 180 degrees. Down here, we talk about a straight angle. A straight angle is basically just a straight line. And hopefully you know, and if you don't, you need to know that a straight line is always 180 degrees. This little circle up here is my degrees symbol, but it got a little big. So that's 180 degrees right there. And those are your angles that you're going to need to classify at some point. All right, as we move along here, there's a lot of writing to deal with. I got a little excited here. Congruent angles. So we talked about congruent in a previous video. Congruent is just another word for equal, but instead of numbers, they're not numbers, right? They're figures and segments and shapes. So we can't say equal, we have to say congruent. Angles with the same measures. So right here you'll notice I have angle A and I have angle B. They have this little arc here, a matching arc. When the arcs match, notice how there's only one arc here. That tells you that any other angle you see in the diagram with one arc has the same measure. If it were to have two arcs, like this angle over here, you would know that these two angles are congruent, but this one is not congruent because it has two arcs. All right, and another little shorthand you need to know is right here. This M, there's an M in front of angle A. That stands for measure. So what it's saying here is the measure of angle A is equal to the measure of angle B, so M for measure, and therefore we can write angle A is congruent to angle B. All right, so we found out that their measures, whatever the degree was the same, and so now we can say that they're congruent. All right, your last page for today. And here is where we actually get to work with numbers in math again. Yay! Okay, so first, if I can get there, we're going to talk about the angle addition postulate. If point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. Oh my goodness, Mrs. Black, what the heck does that mean? All right, let's look at this diagram here. Basically what that's saying, gosh, I should draw this one up here. All right, we have this angle, and we're going to say the angle B is in the interior of angle angle AOC. Pretend that this is an A. All right, so what it's saying is the measure of angle AOB, this portion, and the measure of angle BOC, when you add them together, oh, it's hard to see, my bad, it equals the measure of the entire angle. We're going to play with this a lot, guys, so don't worry, you'll get used to it. So let's actually apply it to some numbers. So we're talking about the measure of angle RQT, which is right here, RQT, and we're going to tell you that it's 155 degrees. You'll notice I went ahead and kind of highlighted it in pink and said it's 155 degrees. We don't know the other angle measures. We don't know this angle right here, RQS. We do know that it is 4x minus 20. And we do know that this angle over here is TQS is 3x plus 14. So what we're going to do is we're going to take each of these expressions for those different angle measures and we're going to add them together. Because this portion of the angle plus this portion of the angle equals the whole portion of the angle. So here we go. Here's some numbers, and we are going to start by combining like terms. When we do that, we're going to get 7x minus 6 equals 155. We're going to simplify some more. We're going to get 7x equals 161. And then once we divide, we'll get x equals 23. Okay, keep in mind, it wasn't asking what x was. It was asking what the measure of angle RQS and the measure of angle TQS are. So we're going to plug that 23 bit back in to RQS. So 23 times 4 minus 20 equals 72 degrees. So the measure of angle RQS is 72 degrees. And then we move down to this one. We plug 23 in right here, and 3 times 23 plus 14 is 83 degrees, and the measure of angle TQS is 83 degrees. And that's it. You guys did it. Congratulations. Have a good night.